Hey, Mr. Yap, is it true that every time there are covalent compounds, we only refer the 3-IMF?
Okay, so you have to be careful here. So we talk about this IMFOA when we are looking at molecules, discrete molecules existing alone. So between themselves, there will be intermolecular forces of attraction. But on a larger scale, on a more gigantic scale, okay, we have to look at other factors.
Alright, which is something that we're going to talk about right now. Guys, so when we're looking at giant covalent structures, the bonding is quite different from simple covalent structures, right? So if you take a good look at your notes, right, you see over there, giant covalent structures, the bonding that they have, we'll call this a giant lattice structure. Right? The main difference is you don't really find molecules inside. You can see in the next bullet, many of them, they are made up of atoms that's joined together. We do not have any discrete molecules combining together. And some of the common examples will be diamond as well as graphite. Okay, let me explain to you guys how diamond actually works.
Hey, stop. I think they are probably sick and tired of hearing us. Like 4 videos already.
Yeah, I guess so.
Okay, so don't worry. I invited 2 special guests today to help me explain diamond and graphite.
Oh, so I can chew.
We can chew.
Okay, we can chew.
Yeah. Okay.
Okay, so we'll leave it to them then.
Yeah. Okay.
Alright, okay.
Hey guys, we have 2 very special guests with us today. We have Mr. Diamond and Mr. Graphite.
Call me Mr. G.
Call me Mr. D. Mr. D, can you give us a self-intro? People associate me with 4 qualities. Now, number 1, my bonds are very strong. That's why my melting boiling point is very high. Number 2, I'm not shockable. Really? Try me. Number 3, throw me in any solvent and I will not dissolve. That's why girls like me. Number 4, I'm extremely hard and rigid. This is me, Mr. Diamond. Okay, so now we have Mr. G. Give us a self-intro.
Okay, I'm Mr. G. I have 4 ideal qualities for a boyfriend. First one, I have very high melting and boiling point because I'm also very strong. I mean, it doesn't look so, but trust me, I'm strong. Second thing is, I'm quite shockable.
Let's try it.
Alright, so I'm a good conductor of electricity. Now, the thing is, I'm just like Mr. D, I'm insoluble in any solvent, so you throw me in anywhere, I won't dissolve. But girls don't like me because I'm just a pencil lead.
Emotional, damn it! Emotional, damn it!
And the fourth thing is, I'm very soft and slippery, and I'm a good lubricant, right?
Okay, thank you guys so much. I hope you guys win the Oscars. It was a great interview. That's it. Bye.
So, William, those were 2 interesting characters, right? Hope they win some awards, man.
Yeah, I'm sure Diamond is going to win the Oscar.
If you say so. Alright, so anyway guys, so let's focus the structure on graphite, not diamond, alright? So let's focus on graphite now. So graphite, the structure and bonding you guys learned in secondary school already, so we will not delve too much into it here. Just want to bring your attention to 2 important physical properties that have a bit of a different explanation in A level. Okay, so the first one being the electrical conductivity.
Oh, the shockability.
Yeah, the electrical conductivity. Okay, so in the structure of graphite, each carbon atom, alright, is bonded to 3 other carbon atoms. So it will use up 3 of its valence electron. The last electron that is not used will be in a p orbital. So you must imagine that every single carbon atom here have a p orbital that contains an electron. So you have all these p orbitals, they will all overlap with each other, and the electrons will therefore be free to move along the entire layer. So we call the electrons to be delocalized electrons. So these delocalized electrons are free to move within the layer. So we say that graphite has good electrical conductivity along the plane. However, these electrons, they are not allowed to move between the layers. Okay, so that's an important thing you might want to take note of as well. Okay, now the other interesting property of graphite is that it's slippery and it has good lubricant properties. Alright, yes, very slippery. Okay, and the reason is because the interaction. So because they are weak, when you apply a small amount of force, they can be easily overcome and the layers can just slide past each other. So that's why graphite is a slippery and a good lubricant. Okay.
Alright guys, it's with great sadness that we have come to the end of our 4-lesson video series. Very sad, huh, Mr. Yap?
Yeah, very sad. Haha.
But we'll leave you in the good hands of our teachers in class. So guys, for the very last time, we are the Chemical Bonding Brothers!